Welcome students. Today's topic is grouping of capacitors. Yesterday we have studied about the capacitors, parallel plate capacitors, energy stored in parallel plate capacitors and energy density of parallel plate capacitors. Now the topic is grouping of capacitors. Just like as the resistances, the capacitors or condensers can be connected in series or in parallel. Now in series I have taken three capacitors. The capacity of first capacitor is C1, its capacity is C2. You can say capacitance also. C1, C2 and C3 are the capacitance of three capacitors which are connected in series. In series, Q is equal to same. Q is equal to same on each capacitor. On each capacitor, one plate is on each capacitor. One plate has positive charge and the other plate has same amount of negative charge. Now we have given the first plate of the capacitor C1 positive charge. Due to induction, these are very close to each other. Due to induction, this becomes negatively charged and this plate becomes positively charged. Now again due to induction, this plate becomes negatively charged and this plate becomes positively charged. Again induction, this becomes negatively charged and this one becomes positively charged. Here it is earth, this positive charge goes into the earth. This figure shows that the capacitor first, second and third, the two plates of each capacitors have the same amount of charge. Suppose that charge is Q, you can say, or small q. What will be the case here? Small q is equal to same on each capacitor. Now since capacitances are different but the charge are same, therefore the potential difference across the plates of each capacitors will be different. Suppose the potential difference across the first capacitor is V1, across the second capacitor is V2, across the third capacitor is V3, and V is the potential difference applied between these 2 points. As we know that potential is a vector quantity, that means V must be equal to V1 plus V2 plus V3. That means V is equal to V1 plus V2 plus V3. Now you can write V1 in the terms of Q and C1. That means Q upon C1. And you can write here Q, because Q is the same on each capacitor, Q upon C2 plus Q upon C3. And what is this one? It can be written as the resultant, that is the same Q and CS, equivalent capacitances. Capacitance when the three capacitors are connected in series. Now Q cancels out from both sides and we get here 1 upon CS is equal to 1 upon C1 plus 1 upon C2 plus 1 upon C3. This is the formula for the capacitors when they are connected in series. Whereas when the resistances are connected in series, the formula is Rs is equal to R1 plus R2 plus R3. This formula is for the resistors. This formula is used when the resistors are connected in parallel. Here the resistors are connected in series, and in series for the capacitor this is the formula. Once again we have taken the three capacitors. The capacitance of three capacitors are different. C1, C2 and C3, they are connected in series. In series I am saying that Q is the same. Suppose we have given the charge plus Q to this plate. Then due to induction, this plate acquires negative charge and this plate acquires positive charge. Now again due to induction, this plate acquires negative charge and this plate acquires positive charge. Now again induction, this plate acquires negative charge and its further part acquires positive charge, which is earth. This positive charge goes into the earth. Therefore, if this plate has plus q charge, this plate has minus q charge. This plate has plus q charge, this plate has minus q charge. This plate has plus q charge, this plate has minus q charge. That means all the plates have the same charge in magnitude, that is equal to q. We can say q is same on each capacitor. Now the potential difference across the each capacitor is different due to their different capacities. Now the resultant V must be equal to the potential difference across the first capacitor, across the second capacitor, and across the third capacitor. That means V is equal to V1 plus V2 plus V3. Now you know that Q is equal to, what is the value of Q? Q is equal to CV. This means V is equal to Q upon C. For V1, since charge is the same, we can write here Q upon C1. C1 is its capacitance, plus for V2, Q charge is the same, and C2 is the capacitance of the second capacitor, plus for third, charge is Q and the capacitance is C3. The Q upon C3. From this, Q comes outside the bracket and Q cancels out from both sides. We get here 1 upon Cs is equal to 1 upon C1 plus 1 upon C2 plus 1 upon C3. But in the case of the resistor, you know that when the three resistances are connected in series, the formula is Rs is equal to R1 plus R2 plus R3, and in series when the capacitors are connected, 1 upon Cs is equal to 1 upon C1 plus 1 upon C2 plus 1 upon C3. This difference should be noted. You have to learn one formula, then for the capacitor, in series, the formula will be the same as when the resistors are connected in parallel. That is your first step. Now the grouping of the capacitors in parallel. When the capacitors are connected in parallel, then what happens? And the second thing is in parallel, grouping in parallel. In parallel. How the capacitors are connected in parallel. When the capacitors are connected in parallel, then you have to take first plate of one capacitor. All the first plate of all capacitors are connected to a point, and all the second plate of the capacitors are connected to another point. This is your first point and this is your another point. This is first plate. This is the first place of the capacitor. All the first plate of the capacitor is connected to one point, and all the second plate of the capacitors is connected to this point in this way. And this is now earth. Second plate's, the outer side of the second plate is earth, and the potential difference between these 2 points is V. That means the potential difference across this capacitor, across this capacitor, and across this capacitor is the same, which is equal to V. Now suppose charge Q is flowing here. In this capacitor, it goes charge Q1. In this one, charge Q2. In this one, charge Q3. Now this plate is positive, but the charge is different, and this plate is negative. Similarly, this plate is positive and this plate is negative. In the same way, this plate is positive and this plate is negative. But the charge on these three capacitors are different. This is your capacity C1, this capacity is C2, and its capacity is C3. Now the charge, due to the conservation of charge, we can say here Q is equal to how much? Q1 plus Q2 plus Q3. Now Q can be written in the terms of the potential difference and the capacitance. You know Q is equal to how much? C into V. you can write here C1V plus C2V plus C3V. And for Q, you can write here CP, means equivalent capacitance in parallel combination, into V. V cancels out from the both sides. We get here Cp is equal to C1 plus C2 plus C3. This is the formula when the capacitors are connected in parallel to each other. And when resistances are connected in parallel, you know here 1 upon Rp is equal to P stand for parallel, S stand for series, is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. Just reverse formulas are there. Therefore, you have to learn only the series and parallel formula of resistances. The formula for the capacitances will be just opposite. It can be reversed also for learning. In the case of the parallel, which is constant, V is constant, and across each plate of the capacitors, because they are connected in parallel, here charge Q is distributed on the first capacitor Q1, on the second capacitor Q2, on the third capacitor Q3. Then Q is equal to Q1 plus Q2 plus Q3. Write the value of Q1, Q2 and Q3, and the Q we will get here Cp is equal to C1 plus C2 plus C3. So this is the formula for grouping of capacitors in series. I am writing here in short, in series, the formula is, you can say, 1 upon Cs is equal to 1 upon C1 plus 1 upon C2 plus 1 upon C3. In parallel, you can say, here, what is the formula? Cp is equal to C1 plus C2 plus C3. You have to learn these two formula. Now there is a question based on this grouping of cell. This is here from NCERT and it is very, very important. It comes 2 or 3 times in the previous board examination. The question is, a network of 4 10 microfarad capacitor is connected to a 500 volt supply as shown in the figure. This figure is given to you. These are your 4 capacitors C1, C2, C3, C4, and they are connected as shown in the figure. In this way they are connected. You have to determine the equivalent capacitance of the network and the charge on each capacitors. Now you can see here this charge, the charge which goes from this one, then this becomes positive, suppose this becomes negative, this becomes positive. Just like as the resistance is same current, same charge is flowing here, same, this one same and this one is same. That means C1, C2 and C3, due to the same charge on each plate, they are in series. From this you can observe 1, 2, 3, the same charge on each capacitor. Therefore these 3 C1, C2 and C3 are in series. We can write here at solution or answer of this one. Answer, you can write C1, C2 and C3 are in series. And the formula is, you know this formula. Therefore 1 upon Cs is equal to, we have to first write the formula C1. Do not substitute the value directly. First write the formula, this one. And what is the value of C1, C2, C3? That is your 10 microfarad. We can write here 1 by 10 plus 1 by 10 plus 1 by 10. 1 by 10 denominator is same. 1 plus 1 plus 1, that means it becomes equal to 3 by 10. Now we can write here 1 upon Cs is equal to 3 by 10. That means Cs is equal to 10 by 3. What its unit? Microfarad. Now you can see here, in place of these C1, C2 and C3, we can write only one capacitor equivalent whose capacitance is Cs. in simplification form, you can draw only one capacitor. This one is one capacitor and its value is Cs. Now from here, this point, the charge is distributed on this capacitor and on this capacitor, but both are connected between the 2 points, same point AD. Therefore, Cs and C4 are in parallel to each other. Once again, in place of C1, C2, C3, we get the equivalent capacitors, that is your Cs. Now Cs is connected in this way. In place of C1, C2 and C3, we place only one capacitor whose equivalent capacitance is Cs. Now you can see here, now between the points A and D, one plate is connected of Cs and C4 is connected to this point. Another plate of Cs and C4 is connected to this point. That means Cs and C4 are connected in parallel between the 2 points. That we can write here, Cs and C4 are in parallel. Here since Cs and C4 are in parallel. ठीक है, figure से. This implies that equivalent capacitance, you can write here C, that is equal to Cs plus C4. Direct, they can be added. Now it becomes here 10 by 3 plus 10. That means 40 by 3. If you simplify this one, we get here C is equal to 13 3 is 39, 13.3 microfarad. This is your first answer, the equivalent capacitance of the network. Okay, now the first answer come. Now the second answer is, I am again drawing the figure, previous figure. That is here, you know, here is one capacitor, here is your second capacitor, and here is your third capacitor. This is your C1, this is your C2, this is your C3, this is your B point, and this is your C point. Now you can see, once again, C1, C2 and C3 are in series because the same charge is flowing between these three capacitors. Therefore, the resultant is this one, its value comes out this one. Now, the resultant of this and this C4 are connected in parallel. Their equivalent capacitance is equal to Cs plus C4, that comes out 40/3. In examination, you may simplify this one, otherwise write the result as such, 40/3 microfarad. Now, charge on each capacitors. You know, in series, the charge on each capacitor is same. Now, see this one. The potential difference across C4 is 500 volt, and the value of C4, you know, we can write it, the value of the charge Q4 directly. What is the value of Q4? Q4, you can write here C4 into V. What is C4? C4 is equal to 10 microfarad. And what is V? That is equal to 500. Then you can write it here, 5000 micro coulomb, or you can say here 5 into 10 raised to the power minus 3 coulomb, because 10 की power minus 6 it is multiplied, or you can leave it as such. Answer is also correct. This is the value of Q4. What are the values of Q1? Because all the three are connected in series, the charge on these capacitors are the same as the charge on their equivalent. That means Cs. You can say here C1, Q1 is equal to Q2 is equal to Q3. That is equal to Cs multiplied by V. And what is the value of Cs? That means 10/3. And what is the value of V? That is 500. You can write it here, 5/3 into 10 raised to the power 3 micro coulomb. If we solve here, we get here 1.67 into 10 की power 3 micro coulomb, or you can say 1.67 into 10 raised to the power minus 3 coulomb. These are the values of Q1, Q2 and Q3. So yeah, you can solve any problem based on the grouping of capacitors. That is the end of today's lecture. You must practice all these topics and this numerical in your copy. Thank you.